Hey kids, time to move on from homogeneous second-order differential equations. But first, let's do this homogeneous from the quiz, right? Homogeneous meaning that our second-order linear, right, because I just have y to the first differential equation is equal to 0. So hopefully you know that your job is to get the characteristic equation, right, using the coefficients 1, -3, and -4 here, and saying 1r squared minus 3r minus 4 is equal to 0. This gives us two real solutions, meaning that when we get the solution y, it is going to be some arbitrary constant e to the 4x, second arbitrary constant, remember, because we have second order differential equation, and that is the general solution. If somebody gave me initial conditions, I could solve for the arbitrary constants. Now, what we're going to do today is we are going to use this same homogeneous equation throughout the lesson, but I'm going to change that 0 to a function so that it's non-homogeneous. I don't know whether to say homogeneous or homogeneous, just don't know. All right, so some notes. The solution to a non-homogeneous second-order differential equation. So we're going to, again, start in the simplest way where A, B, and C are constants, but the second-order linear differential equation is not equal to 0. It is equal to another function. So our solution to the non-homogeneous differential equation is a combination of two things. What you'll be happy to know is that the first part of the solution is what we just found in the warm-up using the characteristic equation. So I call this y sub h, or the part of the solution that comes from the homogeneous component. Right, and depending upon what it is, right, we get our y sub 1 and our y sub 2. For us in the warm-up, that was using our characteristic equation. We got e to the 4x and e to the negative x were our two fundamental solutions. And the second part comes from a solution to the non-homogeneous component. So the right-hand side of the equation. Right? We're going to find a solution that we call particular because it's not going to have constants in it. Right? But it is a particular. Therefore, the overall solution is a combination of those two. The solution to the homogeneous piece and the solution to the particular piece. So the overall solution y is a combination of those two solutions. So we already know how to find this part. What we need to figure out is how to get this part, and we are going to focus today on the method of undetermined coefficients as our way to find the particular solution for the homogeneous component of the second order linear differential non-homogeneous differential equation. So the method of undetermined coefficients only works in for a certain class. So let me make some, like, what the heck? What do you mean that the solution is a combination? So this is kind of sort of the proof, right? If we agree that we have the solution to the homogeneous equation, then it must be true that plugging in my solution, its first derivative and second derivative, right, and doing the math that I'm told to do, then when I do the combinations, I should get 0, right? If I claim I have a particular solution to the non-homogeneous equation, the whole thing, then plugging in the particular solution its first derivative, second derivative, doing the math, right? Whenever I'm supposed to multiply by and do a combination, and I should get g of x. So by the principle of superposition, right? I love that one. The combination of those two is the general solution to the full non-homogeneous differential equation, second order differential equation. So what I've done is, if I'm claiming that this is a solution to the non-homogeneous differential equation, then in place of, I'm going to substitute those in, right? So I have a times y double, the sum of the, right? The derivative of a sum is the sum of the derivatives. Same for the second derivatives. Here's the first derivatives. Here's the original. And that should equal, a little bit of clue of where I'm going here, 0 plus g of x, right? So can you see where I'm going? I'm going to go ahead and distribute, 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 and collect like terms. So I have a, then I also have b. I'm going to collect the homogeneous solutions. Right, so I took care of that, that, and that. Now I'm going to take care of the homogeneous piece. Right? And that's supposed to equal, does that equal g of x? Well, again, you're claiming that you do have a solution here, but what is this piece? That's 0. So 0 plus, yes, then that goes away. Right? So yes, if you have solutions, right, the sum of those two will be the full general solution. So now how do we go about using, so that was just saying, here's why we can do this, why the solution is that sum. Now, given that we agree that we can use the sum of the solution to the general solution to the homogeneous and a particular solution to the non-homogeneous, how do we go about finding that y sub p? So if the function on the right-hand side, g of x, is called an undetermined coefficient function or some combination of the U.C. functions, then you can use the method of undetermined coefficients to solve. So what does it mean to be a U.C. function? G of x is a U.C. function if it is a combination of functions defined by the following list. So you have to pull from this list. G of x has to be, you have to see G of x on this list. Either G of x is a polynomial, that's what x to the n, where n is greater than or equal to 0, but n is an integer, comes from, or G of x is some exponential function, right? E to some x, right? And not e to the 0. Or it is sine of something, where again, you're not gonna make the x go away, or cosine of something. That's it, that's our list. Or some combination of them, okay? Right, so I might have more, I might have a polynomial multiplied by an exponential function. I might have an exponential function times a sine function. But this is what I call my guest list, right? It's like, who am I gonna bring to the party? Where am I gonna choose from? Only I don't call it a guest list, I call it a guess list. Wink, wink. So When I can use the method of undetermined coefficients, the non-homogeneous piece, the right-hand side of the differential equation, has to be from this list or a combination of functions from this list. So let's just dive into an example. You ready? Let's go. So notice the left-hand side should look familiar. So step 1, find the general solution to the homogeneous equation, which means you take the equation and don't set it equal to 3e to the 2x, set it equal to 0. Now, we already did this in the warm-up. So we know that the solution to the homogeneous, okay, there's step 1. Step 2 is 3e to the 2x, a UC function. If it is, remember, wink, wink, we're going to use our guess list to guess a y particular, because remember, don't lose sight of what you're doing. What you're doing here is you're saying some combination of a function and its derivatives with some scalar multiples all combined end up to be 3e to the 2x. Well, how is that possible? That's only, right? E to the 2x, right? E to the x is its own derivative. So all the, right? The original needed to be some exponential, right? The original function y needed to be some exponential. So here's what we're going to do. We are going to say, we are going to wink, wink, guess that the particular solution is an e to the 2x. If that had been e to the negative x, I'm sorry, e to the negative 2x, I would have written e to the negative 2x. If that had been e to the 5x, I would have written e to the 5x here. But it's e to the 2x. So my guess is going to be e to the 2x with an undetermined coefficient. Call it whatever you like. I don't know what it is. So I am now going to find that there is my guess. I pulled e to the 2x, an exponential from the guess list, and shoved an undetermined coefficient in front of it. Now find the first derivative of your guess. And the second derivative of your guess. Step 3, take your guess and its derivatives back to the original. Okay. So y double prime, whoops, minus 3 times y prime minus 4 times y. What is that supposed to be equal to? Okay, that's one equation. And what I'm after is solving for the undetermined coefficient. In this case, I'm not going to need to solve. I'm not going to need to use a system because I've only got one unknown. So I'm simply going to say, what do I have here? I've got 4a So I've got e to the 2x everywhere, right? And I have 4a here, minus 6a here, and minus 4a here. So do you see what's going to happen? I have 4a minus 6a minus 4a are the coefficients all in front of e to the 2x, and it's equal to 3e to the 2x. Right? Divide out the e to the 2x. Four a cancels out, and I'm left with negative 6a is equal to 3. Therefore, a, the undetermined coefficient, is 1/2. This was my undetermined coefficient, and I just found it. What was I after? I forget. I was after y sub p. So what is y sub p? Woot, 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 woot. Oh, no, you're not done, right? Your overall solution is the combination of the homogeneous general solution and the non-homogeneous particular. Step 4, add them together. So y is the combination of the homogeneous and the non-homogeneous. So of course I would make that just a minus, right? Math is so cool. Let's do another one. Ready? So this time I just put, here's all the steps, right? All at once. Notice I have the same homogeneous, so we already know what we're dealing with here. I look at the function that is on the right side of the equation, and I say to myself, self, is sine x on my wink wink guest list? Tis. So I'm going to, y sub p is equal to sine x. If that had been sine 2, if this had been a sine 2x or a sine 3x minus 4, right? That's what I would have written here. But I just copy over the function and then put its undetermined coefficient. However, stop, wait, wait, wait. Go back to what we were, right? What you're doing. You have an original, its derivative, its second derivative, constant multiples, -3 and -4, and then combine them. And you ended up with 2 sine x. If you just have a sine x, what's going to happen when you take a derivative of just a sine x? Right? You're actually going to have a right? To get derivatives that end up, right? Your cosine ended up canceling out because when you take derivative of sine, you get a cosine. So you need to also add cosine x here. I didn't have to do that with e. E was its own derivative. Sine is not its own derivative. Sine has a cosine derivative. Cosine then has a sine derivative. So do you see where this guess list is coming from? Either sine or cosine, right? Those derivatives circle around in sine to cosine to sine to cosine and, positives and negatives. E to the x just spins around itself. The derivatives of e to the x is e to the x is e to the x. So don't forget this piece. Now go on with yourself and take derivatives. What is the first derivative? Minus, and what is the second derivative? Minus I'm done changing color in between there, so I'm just going to kind of do this. I have A and B are my undetermined coefficients. Okay, I didn't have that situation with exponentials. So now I am going to take, right, y, plug it in here, y prime here, and y double prime here, and try to solve for the undetermined coefficients. So I'm going to need some more space for this, and then don't forget my last step is to combine step 1 and step 3. All right, so there's my undetermined coefficient function and its derivatives. So I'm going to go up here and plug it in, y double prime minus minus 3 times y prime minus 4 times y. And watch what I do here. This is supposed to be equal to a combination of sine x and cosine x with known coefficients. What is the coefficient of sine from the original? And what is the coefficient of cosine? Oh, snap. So your job is to line up all the sine, right? Line up all the sine terms. So what do I have? I have negative a sine x. Then I have negative 3 times negative b. That's a positive 3b sine x. And then I have a negative 4a sine x. I'm just lining them up this way because, well, hopefully maybe you'll see why I'm going to line them up this way. Then how about your cosines? What do you have for cosine? So I have a negative b cosine x. I have a negative 3a cosine x. And I have a negative 4b cosine x. And those, if I lay those out, right, in all linear, they're all supposed to, in one line, they're supposed to equal 2 sine x plus 0 cosine x. Well, what do I have here? Look at your sine x. What are the coefficients on sine x? I have a negative a and a negative 4a, so that's negative 5a plus 3b are the coefficients in front of sine x. How about in front of cosine x? What do I have? Negative 3a and negative 5b. And again, that is supposed to equal 2 sine x plus 0 cosine x. So do you see what I'm going to do here? Bam, baby. Here's my system of equations. Negative 5a plus 3b has to equal 2. Negative 3a minus 5b has to equal 0. I think I'll multiply both sides. I'll multiply that by 5/3. So I get negative 25 over 3a plus 5b is equal to 10/3. And now I will add down. So by 10 over 3. And what is that? Negative 9 over 3. And negative 25 over 3 is negative 34 over 3. Multiply through by 3. A is equal to, what is that? 10 over negative 34, so negative 5 over 17. How do you find B? Right, take A, plug it in here. And if you do that math, you're going to get B is equal to something over 17. That's going to be nice with 5. That's going to be 3 over 17. What have you found? This A and this B. Therefore, the general overall solution is the homogeneous plus a particular A sine x and B cosine x. Whoa, done and done, baby. Let's do another one. So think about our guess list. I did an example where the right-hand side of the differential equation was an exponential. Now I did it when it was sine, same process if it was cosine. What am I going to do now? Polynomial. Same homogeneous equation. Done. Is for x squared on our wink wink guess list. Tis. So my guess for the particular solution is a quadratic x squared plus x to the first plus a constant. My undetermined coefficients are A, B, and C. Okay, think about again what we're doing. I have a y whose first and second derivative with some multiples of the original and the first derivative combined with its second derivative, the other polynomial stuff drops out and I get, right, the other powers drop out and I have an x squared left only. Now remember, when you have an 4x squared, what do you really have? I always do that. Okay. So then we're going to substitute. Oh, wait, first I got to find the derivatives. So what is the first derivative of this particular? And the second derivative of that particular. Right, this is my guess. Did its derivatives. Now I'm going to substitute back into here. So y double prime minus 3 times y prime minus 4 times y. And that's supposed to equal 4x squared plus 0x plus 0. So, right, your job, just like we did before, is to line things up and using the equal sign, whatever coefficients are in front of x squared over here need to be equal to 4. Whatever coefficients are in front of the x term need to be equal to 0. And whatever an x to the 0 all of those constants need to add also to 0. So let's start, just because I like starting with the highest power. I only have one x squared term, and what does that need to be equal to? Negative 4ax squared. Shoot, I don't want the x squared piece, just the coefficient on x squared. What does that got to be equal to? 4. Therefore, what is a? Easy peasy. Check. Now, how about the x term? What do I have? Negative 6a, right? Negative 6a is in front of that x, and then I have negative 4b. And what does that have to be? Those are the coefficients in front of x to the first. What does that have to be equal to? Good. Now, I'm going to kind of use this situation, right? So I have negative 6 times negative 1, which is positive 6. Subtract 6. And oh yeah, that is positive 6. I get 3 halves. Just double checking my sign. If you make a mistake here, it's going to be a sign, right? So I did have negative 6, right? Times negative 1 gave me a positive 6. Yeah. And then I did have a negative 4b, right? Okay. Now, how about the constants? So check, I did that. So 2a minus what? 3b. And then minus 4c has to be equal to 0. But I already know a And I know B. Now I just need to solve for C. So -2 minus 9/2 is equal to 4C. What is that? -4/2, so that's -13, right? Keep my math legit here, is equal to 4C. Therefore, C is equal to -13/8. And I didn't have to solve a system this time, which is super nice. So my final solution is the combination, the overall general solution to the homogeneous piece, minus A plus B plus C. Woot, woot. All right, so that's about it for the method of undetermined coefficients for today. So I'm going to do one more example, and you're going to be like, no, but then you're going to be like, yes. I'll show you why. And this is going to lead into what might happen down the road in our next method of undetermined coefficients. So I see what's happening here. I certainly don't have a 0 over here. Oh my gosh. What is happening? But notice that each one of those is a UC function. To use the method of undetermined coefficients, I can deal with g of x over here being lots of stuff as long as it is some kind of combination of our guessed list. Guess, wink, wink, list. So I'm still good to go. And what's nice about this is that the combination was just a simple sum. So what do you think the solution is going to be? That's right. You love your combos, baby. Combos of problems. If this problem had just been given to me straight up, I would have done example 1, 2, and 3 first, separate problems, right? I would have done 1, 2, 3, and then my overall already, and don't forget though, actually, I would have done 1, the homogeneous, then 2, 3, 4, I should say. So my overall solution is the homogeneous solution, general solution. And then, right, this is the law of superposition again, or the principle of superposition, whatever it's called. Where this was y p sub 1, this was the second particular solution, and this was, all right, this is bothering me now. I should have just called this h, right? Y of h plus 1, 2, 3 particulars. So the first one was -1/2. Our a was -1/2. Remember, that was, we only had a. Then we had the sine and cosine one. Oh my gosh, I didn't do such a great job with my space. And then we had the third one, where a was x squared, b was 3/2 x, and c was negative 13/8. Whoa. What now, you say? Mic drop. So the problems I gave you from the book tonight are either, right, a second order non-homogeneous differential equation where the right-hand side is exponential, the right-hand side is a sine or cosine, the right-hand side is a polynomial, or the right-hand side is a combination of all three or two or whatever. And then the last problem, number 13, is an initial value problem, right? Which just gives you a, right, a point on y and a slope from y prime, and then you will solve for the constants, the unknown constants, okay? So what's going to happen as a foreshadowing, what's happening later, what can get messier? So obviously things can get messier with a system of equation, but also the only combination I've done is an adding. What happens when the combination is multiplying? For instance, if my right-hand side had been 4x squared times this, or another thing happens when our homogeneous equation has a double root, right? And so you kind of remember what happened with that with homogeneous. So we're going to have to deal with that also in a non-homogeneous situation. But that is for another day. I will see you at our next live session. Bye.